action of cyclic GMP is mediated by? Okay, first of all, this is the wrong question, because cyclic GMP is a part of the second messenger system, so it mediates action of some hormone. So this should have been framed like the cyclic GMP mediates action of which of the following hormone, or it should be like cyclic GMP signals the or carries the intracellular signaling of which of the following hormones, right? That should have been the right framing of the question. Okay, now when you look at all these hormones, right, whenever we talk about a hormone, what is the basic understanding? Hormone is a chemical substance produced by an endocrine gland which directly do not act at the site of its release, right? So it is released by cells, endocrine cells release it. So if this is an endocrine cell, it releases a hormone. The hormone has to travel to act at a distant location, and the medium of its transportation is usually the blood. So the hormone is usually released into blood. It will travel through the blood to reach its target organ or the target cell, and on the target cell it should have a receptor, right? So if this is the target cell of the hormone should come and bind to its receptors, and whatever the hormone needs to achieve on the cell, all the intracellular signaling will be taken by a second messenger system, right? The receptor may be on the cell membrane, or maybe in the cytoplasm, or maybe in the nucleus. Now if it is a steroid hormone, right, its receptor is usually in the cytoplasm or directly in the nucleus. All the peptide hormones, their receptor has to be on the cell surface, right? So if I'm taking the example of a peptide hormone, then the receptor will be on the cell surface, so this hormone will come and bind to the receptors. Once it binds, the constitutional changes triggered in the receptor will activate a second messenger system. So this will activate a second messenger system, and the second messenger system will communicate with the cells to bring out the desired action from the cell. This is a basic action of hormones. Okay, now these receptors themselves are categorized into various types based on what is the second messenger system that they are using. Okay, so let us look at the hormones listed here. So when I talk about ACTH, right, it is coupled to a G protein coupled receptor. So the receptor for ACTH is a G protein coupled receptor, and its a second messenger system is cyclic AMP. Cyclic AMP is the second messenger for the ACTH. So the ACTH receptor is GPCR, its second messenger system is cyclic AMP. Okay, now coming to insulin. Insulin is coupled to a receptor known as receptor tyrosine kinase. Receptor tyrosine kinase, or RTK, right? So it is coupled to tyrosine kinase activity, having the receptor having tyrosine kinase activity. Now oxytocin is also coupled to a G protein coupled receptor, and its second messenger system is, can anybody tell me what is the second messenger system of oxytocin? Its second messenger system is IP3 diacylglycerol pathway, right? IP3 DAG pathway. So it will be using the phospholipase C as the enzyme involved in the second messenger communication. Now coming to nitric oxide, right? What is the basic action of the nitric oxide in human body? To cause vasodilatation, and that vasodilatation is mediated through cyclic GMP. Cyclic GMP is the second messenger system for the nitric oxide. So for this question, the answer should be nitric oxide. That's it, guys. Thank you for listening.